Right, I'm continuing from the last day lesson. There we have just learned about the arithmetic operators in Java and how we can use them. Right, so these are the operators that we have learned, and especially we learn about this increment and decrement part. Actually, we learn two kind of increments, postfix and prefix. Then we learn about the two kind of decrements, that is also postfix decrement and the prefix decrement. So what are the other operators? So I said that we are having comparison operators. Sorry, assignment operators. Assignment operators means like you are assigning something. So that is much similar. So only difference is once you calculate the here like plus equal, x plus equal 3 is x equal x plus 3, means whatever you have done in the operation will be reassigned back to the variable. That means x value will be changed. But if you just say x plus 3, it will not change the x values, no, value of the x, no. But if you say x plus equal 3, it will change the value of x and will make it equal to x. It will be equivalent to x after the operation. Actually, after the operation also the variable value will be changed. That is what the assignment operator is. And actually the bitwise operators are here. You can see some bitwise operators, AND operator, O operator, XO operator, and then shift in left and right. So we skipped few times since these are binaries. We skipped these things few times. I think now it's time to do these things too. So what are these bitwise operators? Actually, so it will operate things according to the logic gate processes. So which means like, so there are few logic operations that we need to know. So O operation, AND operation, and NOT operation, how these things are happening. So let me explain that. If you not something in the NOT operation, when you input 1, it will output 0. It will be inverted. When you input 0, it will be inverted to 1. So that is the NOT operation. Very simple. When you input something, it will be converted to the other version of it. Right? So zeros will be there because we have two versions, one is zeros and ones. Zeros will be converted to ones and ones will be converted to 0. So that is what happened in there. Okay, then what about O operation? In the O binary, this O binary logic, so what really happens in the O binary logic basically? So if you, so this is like there are two operations considered. O is denoted by plus mark. 0 or 0 is equal to 0. That means if both inputs are 0, then the output will be 0. 0 O, this is read as 0 O, right? 0, not 0 plus, 0 O 1, result in 1. 1 or 0, also 1. Similar to addition, but there's a difference. 1 or 1. 1 or 1 is also 1. And this is how the operation works. Actually, when all the inputs are 0, you can see it will output 0. But if put at least one of the input is 1, it will output 1. That is the nature of operation. This will be common to 3 operands too. That means 0 or 0 or 0. So what will be the value? It is 0. Then what about 0 or 1? So that is 1. Then 0 or 1 or 0, that is also 1. At least if there's 1, that is 0 or 1 is also 1. Then 1 or 0 or 0, 1 or 0 or 0 is also 1. So
That is how that behaves. Actually, there are more combinations. So let me write the other combinations too. 3 more combinations left, and that is here. That is 1 or 0, 1, and 1 or 1 or 0, the 1 or 1, and so on. So this is how the OR operation works, right? Then the final is not operation. Sorry, AND operation. So here, similar to the operation, AND operation works. The symbol of AND operation is dot. So we have to replace all these pluses using dot. You can write down this with me to save your time. So you better write down rather than taking screenshots. So do not take screenshot for this one, because this one you need to write down somewhere. The reason is this, because this is needed for many places. You need to be aware about this. If you write down, you can remember this very well. So what is the AND operation? In AND operation, if both are 0, 0. If 0 and 1 is also 0. 1 and 0 is also 0, but 1 and 1 is 1. AND operation, when all are 1 only, it will output 1. So that is the nature of AND operation. Here also, at least if there's 1, 0, it will be 0. But if all are 1, only it's 1. That is AND operation. So let me write down what happens there. Not will invert the input. O. So what is happening in O operation? If all inputs are 0, then the output is 0. Otherwise, it's 1. Right? Otherwise, it's 1. In the AND operation, when all inputs are 1, then output is 1, otherwise 0. Okay, this is the easiest way to remember these 3 operations. Okay, quickly write down this. Like when you write this alone, this will be needed everywhere. Maybe when you're doing your mathematics lesson, when you are learning for electronics someday, this will be needed. Therefore, this logic gate, this is actually called the truth table representation of that logics. And this is what the truth table is, but I didn't explain that much because this lesson is not about the logic gate. I just want to explain the logical behaviors of these operations. That's all, right? But so we will learn this as a logic gate and truth table in a separate lesson, especially when you are learning electronics. And if you're learning for computing, basically the logic gate is there for ALU design, memory design, ALU design. This part is there. But since our main focus is to learn about the programming, I'm not going to focus much on that, but you can explore this. It's very easy. So only thing is you have to identify the number of inputs. If number of inputs are 1, then the output will be 2 to the power 1. That is two combinations. Number of inputs here, NOT gate will take 1 input. Therefore, 2 to the power 1, 2 combinations will be there. That is 1 and 0. If OR gate will take minimum of 2 input, it can be 3, 4, 5, any number, right? So if there are 2 inputs, 2 to the power 2. 2 to the power 2 is 4 combinations. Then how we are writing the 4 combination, we have to toggle. Toggle means 0, 1, 0, 1, then 0, 0, 1, 1. This is how you write the 4 combination. 3 inputs, 1, 2, 3. If there are 3 inputs, so that is 2 to the power 3. 2 to the power 3 is 8. 2 to the power 3 is 8. 2 into 2 into 2. It is 8. So 8 combination, you have to toggle it 0 1 0 1 0 1 0 1 again. 00 11 00 11 and 4 zeros 4 1. That is how you are toggling. Then and get same concept. XO also the same concept. Let me explain the XO now. So what is this XO operation? Actually, so in our childhood, maybe you are when you are in grade 8 or grade some lower grades, sometimes you learn the XO operation as something like this. When both are similar 0, both are different 1. Right? So this is very simple method of learning. When both inputs are 0, it is 0. When both inputs are equal, that is 0. When the inputs are different, it is 1. But that is only applicable for 4 inputs. Sorry, 2 inputs. 2 inputs mean 4 combination. Because here you cannot check because you don't have both. There are 3. When all 3 are equal 0, all 3 are equal 1. So this is 0. That is not acceptable. So therefore, let's learn the real theory behind what is actually happening. Actually, so this is what happening if number of ones in the input is odd, then output is 1. So that is very simple. If number of ones in the input is odd means odd numbers, 0 1 1 is odd number, then output is 1. Here also you have only 1 is an odd number, therefore output is 1 1, that is 2 ones are there, 2 ones are there means odd, that is not odd, that is even means it is 0. So that is easily applicable, and the like symbol is this is how really we are drawing the symbol. X operation, we have to draw plus like O operation. After drawing the plus, we are drawing a circle surrounding that. That is the actual way of drawing X operation. But since I cannot draw that in the notepad, so this is how the X operation is actually there. If you want to draw, but in programming you can't draw this symbol plus and surrounding circle. You can't write this in normal ASCII. Therefore, there is a way of doing that. So instead of writing this, it's writing like this: cap shift and 6. Shift and 6 will give you that shift 6 and shift 6 here also. Can you try to draw this like, can you try to write the output for 3 inputs, considering the theory, like if number of ones are odd, then the output should be 1. So please write down this in your book and try to find out the answer or the result of this operation. This is XOR operation. Okay, these are not the answers. I'm just erasing that. These are not the answers. So try to find out the answers. When you write XOR operation, what is the theory? Inputs, when number of ones are odd, then the output is 1. That is the process.
So
Can you tell me
This
the
meeting is
answers?
being recorded.
the first one is 0.
Huh?
Second one is 1.
Okay.
The second one is also 1. The fourth one is 0.
Yeah, there are 2 ones, 0.
The fifth one is 1.
Okay.
That's 0.
Hmm.
That's also 0.
Yeah.
And that's 1.
Yes, correct. Yes, correct. That's it. It's not difficult, right? It's easy. That is the nature. Okay. So let's save this as Bitwise. Bitwise operators. Okay. Right. That's it. And right. So, but when you need to apply these operations to the integers, and we are normally applying these operations for the integers. First, what you need to do, let's say 5 and 7. What you have to do is first you have to convert that using that into binary. Otherwise, you will not be able to apply this now. I think you can remember how you did this in grade lower grades, right? You have done the conversion. I think you can remember that. Hopefully, are you or not? Can you remember how we have converted to binary? So when there's 5, 5, 5.
They never taught us like in lower grades how to convert to binary.
Oh, so 5 divided by 2 is, what is the answer? 2 and remainder 1. Then 2 divided by 2 is 1, remainder 0. You will take from bottom to top. Then 5 is 1, 0, 1.
Oh, okay.
You remember that?
They never taught us that, but it seems simple enough to understand.
Right, 7, do the same.
Okay.
7, just divide by 2 is 3, remainder 1, divide by 2 again, that is 1, remainder 1. So 7 is 1, 1, 1 in binary. Right, then what you need to do after conversion? So then you have to write down these binaries this way: 1, 0, 1, 1, 1, 1. Then AND it. When you are ANDing, just AND the correspondent digit. This one, this one, and this one is one, and this one is. So when you AND it, like 1 and 1 is 1, 0 and 1 is 0, 1 and 1 is again 1. So the answer is convert back to the decimal, it is 5. So that is how done. We can show this example. 5 and 7 is 5. Actually, this even like this can be practiced in Python too, right? It also supports this bitwise operators. You can type 5 and it's very easy. 5 and 7. See, 5 and 7, but it is not showing these intermediate steps how this happens and all. And just, yeah. Okay. Right. Let's do another one. I need to find out 9 and 16. 9 and 16. Then 5 XO 5 or 11. Then 12 or 12 or 17. You are trying. So, these are comments. If you can understand this mathematically, then that is what happened in the programming side, and then we have to learn about the shifting operand. Quickly go through that. Send me the answer if found. Just send me the answer to chat. Like first one, what is
This meeting is being recorded.
9 and
Okay.
6.
For 9, I got 1, 0, 0, 1.
Correct. 9 is 1, 0, 0, 1. Correct.
And for 16, 1. I wrote it down. It is Oh wait, that's the one I didn't do. Okay. Give me a moment.
Okay.
Let's quickly.
Then you can just convert 16 divided by 2 is 8, the remainder 0. Divide by
Yeah.
2 again, that is 4, remainder 0. It's divisible, right? Divide by 2
Yeah,
again.
it's
2
pretty. Yeah. So okay, I got it. 1 0 0 0 0 0.
1 and 4 zeros, right?
Yeah.
1 0 0 0 0. When you add this, 1 and 0 is 0. 0 0 is also 0. 0 0 is also 0. 1 and 0 is 0. Here you can put 0 in front of, right? So there is also 0. So all zeros.
Yeah.
You got it? All zeros.
Mhm.
Let's try it using a programming language, the easiest way is Python. So let's go to the shell, Python. I need 9 and 16. The answer is 0. You can see 9 and 16. The answer is 6. Right? So that is how it comes using the AND gate. 9 and 0. The answer is 6. Okay. So let's try the next one. Can you tell me the next one? 5
Yeah.
is
So 5 is 0 1 0.
oh,
Oh
5.
wait, hold on. 0 1 0 0.
Oh, 1
That's right.
0 1. 5 is
Oh,
5
1
divided by 2 is 2
1 0.
remainder 1. That divided by
Yeah.
2 is 1 remainder 0. That is 1 0 1, right?
Yeah, I was reading off the wrong one. Sorry.
Then 11.
Sorry.
2 is 2 remainder 1 and divided by 2 is 1 remainder 0. 11 is 1 0 1 1.
1 1.
So
Yeah.
let's write them together. 1 0 1. The other one is 1 0 1 1. The X operation. X operation, if it is even, it is 0, or it is 1, or it is 1, or it is 1. So the answer will be 1 1 1 0, which is 14, right?
Yeah.
You got it?
Yeah, I got
The
it.
answer is 1 1 1 0. 1 1 1 0. What is the value? It is like here you have ones, here you have twos, here fours, always double, here eights. This is how you reconvert. 1 from 8, 1 from 4, 1 from 2, 0 from 1. So 8 plus 4 is 12 plus 2 is 4. That is how you
Oh, okay.
reconvert.
Okay.
Okay.
Yeah.
Then let's try this using Python shell. Okay, what is the value? The first value is 5. The second value is XO 11 and answer is 14. Understood how you got it? Or not?
Yeah, I understand.
12 or 17?
I understand. 12 and 17.
12
For
or 17?
12, I got.
12 is?
For 12, I got 0 0 1 0 0.
Oh. Okay. 12 divide by 2. Can you tell me the answer? 6 remaining
Yeah, 6.
0.
6 remaining 0.
Okay.
And
Then
then
3
it's
remaining.
3 remaining 0.
Okay.
And then it's 1 remaining 1.
Okay. Then you are reading from bottom to top. 1 1 0 0.
Oh, I added an extra step at the end. That's why. Okay. Never mind.
1 1 0 0. You are reading from bottom. 17.
17. So for 17, I got 1 0 0 0 1.
Yeah. 1 0 0 0 1. 12 is 1 1 0 0. Then you have to O. O means if both are 0 only 0, this is 1. But both are 0 here, 0 1 1 1. You will get this. So what is the value?
The value is
Here you have ones, here twos, here fours, 8 and 16. Now you have to add them. 1 from 16, 1 from 8, 1 from 4, 0 from 2, and 1 from 1.
31.
0 from 2. 16 plus 8 is 24. 24 plus 4 is 28 plus 1, right? This is not added because this is 0.
Oh, yeah, 29.
Then it's 29. So here the answer is 12 or 17 is 29. Right? 12 or 17 is then not 5. Not 5 is basically minus 6. So there is a special way like how this happens. So that is actually all two's complement representation. You don't know that. Okay. When you have a number 5, it is 101. Since it is positive, it will be written as 6. So normally these numbers are 32-bit. So 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 22, 24, 25, 28, 29, 30, 31. This is how it is represented as a 32-bit integer. And when you not it, what will happen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 22, 23, 24, 25, 27, 29, 30, 31, 32. Reverse. Normally, when the first digit is 0, it thinks this number is a positive number. Computer identifies the number as a positive number. When the first digit is 1, the computer will identify this as a negative number. That is why when you invert 5, you got a negative number. Not 5 is a negative, but if you not the other way, like not a negative number, not minus 6, that will be positive 5. Not minus 6, that was negative number. If you not it, it will become positive. Positive number, if you not it, it will become negative. That is the. And how this extra bit comes, why there's a gap? Because this number, when you are converting, there is a method. You will invert and add 1. When you are converting back, you will invert and add 1. Okay. That means when you are finding the number, first you invert. So when you invert, you will get negative 101. Because when you invert this is 101. That means this is negative 5. But you need to add 1 to this. Negative 5 minus 1. So that is the method actually. That is why you got negative 6 here. So similarly, if you are inverting a negative number, you will put positive, and then the negative number, like if this is, let's say this is the negative number, when you invert that, you will get 5 and then plus 1. So that will become positive. That is the reason, right? When you invert a negative number, how it become positive? Positive number, it will become negative. The reason is that actually this is due to the 2's complement. Still we have not learned the 2's complement, so don't worry much about that. Just think If you are not in positive number, you will get 1 less than the particular positive, 1 less than. That means, so let's write something like this: not 100 days, not 100 days, minus 101. That is 1 less than the negative. But sorry, one value more than, but the negative value is basically 1 value more than that. So not 2006 is minus 2007. But if you do the other way, not minus 999 is plus 1000. Sorry, so it is reverse. It is 998. It get 1 less than. The negative one you get 1 more than, the positive one you get. So just remember like that. That's enough. Don't think much about that, because still we have not learned about. Okay, that's it. And that is what we need to learn about these operators. And shifting is another important thing. In shifting, what will happen? Shifting is very simple. Like, let's say you are shifting. Okay, let's take a number. 9 is 1001. You are shifting it. You are shifting it. Let's draw a shape here. This is like a wall. This is sorry, this is like a wall. You are shifting it right side. When you're shifting this number right side, just you're pushing this to the right. 1001. Actually, when you're pushing this to the right, what will happen? Can you see? Earlier it was 1001. When you're pushing to the right, it has become 100. Understood? If you push one more time, if you push, what will be the result? It is 10, right?
Yeah.
10. One more time, if you
1.
It is 1. So this is what pushing right is. Pushing right. So what will happen? So let's see that using same pattern. You have 9. 15 to right side by 1. So it has become 4. How? 100 is 4. 9, you're shifting it 2 times. That is 2, right? 10 is 2. Yeah. 9, you are putting 3 times. It is 1. What happens if you put 4 times? Nothing left, right? 0. Yeah, nothing left. So that is what the shifting is. And that is shifting is like just you are pushing it to that side or moving it to the right side. You have to think there's a wall. The other digits are falling, or other digits are like going away from the wall, not visible. The visible digits are taken as well. That's good. Or not? Okay, let's do another one. Okay. So what is 70? It is 100,001, right? Correct? No.
Yes.
Oh, 100, 1, 2, 4, 8. Yeah, 100,001. Check with your answers.
Yeah, it's 1001.
Okay. Then right shift this by 2. Can you tell me the answer? Right shift this by 2. You are right shifting the value of this by 2 position. What will be the result? Yes. 100, right?
Yeah.
Right. That is, what is the answer then? 100 is 4.
Yeah.
17. You right shift by 2 positions. That is 100. Got it?
Yeah.
Right. The left shift. Actually, right shift is similar to dividing by 2. 9 divided by 2 is 4 without the remainder. 9 divided by 9 divided by 2 and again divide by 2. 9 divided by 2 is 4, again divide by 2 is 9 divided by, this is actually 9 divided by 2, again divide by 2, again divide by 2. Okay. So the reverse is similar to multiply. Reverse is similar to multiply. That means you have a number. Okay, you have a number. Let's take a number. I'm writing, okay, 16. 16 is 1000. Yeah, left shift in that, left side, 10000. Because left side, it should, if you are left shifting again, it is 10000. Left shifting means you are moving to the left side. Understood?
Yeah.
What is that? That is basically multiplying. Right shifting is like dividing, left shifting like multiplying. Okay, let me do 16, left shift by 1 position. Now it is 30. 16, left shift by 2 position. 66, multiply by 2 and again multiply by
2.
Understood? 4. Okay, tell me 4. Left shift by, okay, next 5. Left shift by 2. What is the value?
5 left shift by 2 is... Oh, wait, hold on. I have the thing. 5 left shift by 2 is 10000. So that is...
Yes.
Wouldn't it be
Left shift by 1. When you left shift by 1, 5 will become 10.
yeah.
1010. Again left.
It will be
10 will become
20.
20. Yeah, 10 will become 20.
Okay.
Understood?
Okay. Yeah.
Okay. 6.
Okay.
Left shift by 4 times.
6 left shift by 1 is
12.
12, then 24, then 48, then 96.
Right. Now you can understand the size operators. We skip this in Python, but we can't skip in this, like we cannot do it continuously. Therefore, I decided to now know how this binary are working. We have to think the binaries. You will forget this. It's not usually using. We are not usually using. So this is rarely we are using the shifting operation, especially in encryption and some other algorithm development. So basically rare. Therefore, you will forget this very soon. So what you can do is just refer to the video back. I'll upload back the video and even take a screenshot of this. And just then you can recall from that. Right. Okay.
Okay.
Okay, let's stop from here. Then when I say bye.
Okay. Bye.